Good day everyone. For today, I will going to discuss to you about Internet Protocol Security or the IPsec. So IP security or IPsec is an Internet Engineering Task Force or IETF standard suite of protocols between two communication points across the IP network that provide data authentication, integrity, and confidentiality. It also defines the encrypted, decrypted, and authenticated packets that protocols needed for secure key exchange and key management are defined in it. Next is the uses of IP security. To decrypt application layer data, to provide security for routing data across the public internet, to provide authentication without encryption like the authenticate that the data originates from a known sender, to provide authentication without encryption like to authenticate that the data originates from the known sender, to provide network data by setting up circuit using IPsec tunneling in which all data is being sent between the two endpoints is encrypted as with a virtual private network or VPN connection. And for the IPsec security features, we have authentication. It verifies that the packet received is usually from the claim sender. Next, integrity ensures that the contents of the packet did not change in transit. Lastly, confidentiality conceals the message consent through encryption. Next is the IPsec components. First, encapsulating security payload or ESP. It provides confidentiality, authentication, and integrity. It also provides authentication for payload. Next, authentication header or AH provides authentication and integrity also. So it provides authentication and anti-replay, and it does not provide encryption. The anti-replay protection protects against unauthorized transmission of packets. It does not protect data's confidentiality. Next is the Internet Key Exchange or the IKE, provides key management and security association or SA management. So IKE it is a network security protocol designed to dynamically exchange encryption keys and find a way over security association or SA between two devices. Next is for the understanding IPsec modes, which is the tunnel mode and transport mode. When we say IPsec tunnel mode, it is the default mode. With tunnel mode, the entire original IP packet is protected by IPsec. This means IPsec wraps the original packet, encrypts it, adds a new IP header, and sends it to the other side of the VPN tunnel or the IPsec peer. So, in this example, each router acts an IPsec gateway for their LAN, providing secure connectivity to the remote network. The client connects to the IPsec gateway. Traffic from the client is encrypted, encapsulated inside a new IP packet, and sent to the other end. Once decrypted by the firewall appliance, the client's original IP packet is sent to the local network. In tunnel mode, an IPsec header or AH or ESP header is inserted between the IP header and the upper layer protocol between AH and ESP. ESP is mostly commonly used in IPsec VP and tunnel configuration. So the packet diagram below illustrates IPsec tunnel mode with ESP header. ESP is identified in the IP header with an IP protocol ID of 50. Next, the packet diagram below illustrates IPsec tunnel mode with AH header. So, authentication header can be applied alone or together with the ESP when IPsec is in a tunnel mode. AH job is to protect the entire packet. The AH does not protect all of the fields in new IP header because some change in transit, and the sender cannot predict how they might change. AH is identified in the new IP header with an IP protocol ID of 51. Then next, the IPsec transport mode. IPsec transport mode is used to end-to-end communications. For example, for communication between a client and a server or between a workstation and a gateway if the gateway is being treated as a host. So a good example would be an encrypted telnet or remote desktop session for a workstation to a server. So the packet diagram below illustrates IPsec transport mode with ESP header. So notice that the original IP header is moved to the front, placing the sender's if IP header at the front with minor changes to the protocol ID. Proves that transport mode does not provide protection encryption to the original IP header, and ESP is identified in the new IP header with an IP protocol ID of 50. Then lastly, the packet diagram below illustrates IPsec transport mode with AH header. So the AH can be applied alone together within the ESP. When IPsec is in the transport mode, AH job is to protect the entire packet. However, IPsec is in transport mode does not create a new IP header in front of the packet but places a copy of the original with some minor changes to the protocol ID. Therefore, not providing essential protection to the details contained in the IP header. AH is identified in the new IP header with a protocol ID of 51. So that's all, and thank you.